Welcome you all back to my video. This is Vimala Devi. I have two model question papers of ATC. The code is 18CS54. One which is released for ISA department and another one which is released for CSA department, and model wise questions are there. I already started solving these questions module wise. Today we are going to have a discussion on how to minimize the given deterministic finite state machine. So this is a problem I have taken to solve today. Of course, I'm going to explain or give the definition, and this problem I'm going to solve also. This is ISE question paper. In another video, I will solve the question which is given for the computer science and engineering students also. Fine, let us get back to the question now. So already I have partially defined the definition. So first we have to know what is distinguishable and indistinguishable states, right? And also we are going to learn how to minimize the deterministic finite state machine. We know that deterministic finite automata is nothing but a collection of states and transitions. We are able to find the equivalent minimized DFSM for the given DFSM by this method. Okay, how to do that? So we should be able to identify which are distinguishable and which are indistinguishable states. For example, let us consider like this. There are two states, P and Q. These two states are not distinguishable, or I can say indistinguishable, when for all the strings which belongs to the given alphabet. So from the state P, the machine is reading the string W and it reaches the final state. From the state Q, the same string is read by the finite state machine and it enters into the final state. See, after reading the string from the state P and the state Q, the state what it is reaching is the final state. So I can say that now P and Q are indistinguishable states. If P and Q are not distinguishable, then you can call it as indistinguishable states. Okay, now we move on to the other partial definition. When can we say the states are distinguishable? It's very simple. There exists a string W. Of course, the string belongs to the given alphabet. Okay, so delta, you know that it defines the transition function. From the state P, we want the machine to read the string W. We assume that it enters into the final state. Whereas for the same string from the state Q, if it reads the string and if it is entering into the non-final state, see, it does not belong to the final state. From the state P, after reading the string W, it enters into the final state. But from the state Q, on reading the string, it is entering into the non-final state. In this case, P and Q are distinguishable. So this is a basic definition. Now we are going to solve the problem. So what is the first step? The first step is nothing but finding the equivalence class 0. What is equivalence class 0? You are going to find the distinguishable and indistinguishable states when the length of string is equal to 0. That's why we are calling that distinguishable set of states is available at the level of equivalent 0. So what is the first step? First, simply separate the final and the non-final state. So this is a given problem. The first column tells all the states. There are two input symbols. One is A, another one is B. You know the meaning of the transition table. From the state A, on reading the A, it goes to the state B. From the state A, on reading the B, it goes to the F, and so on. So this is a transition table given for the problem. Suppose the problem is given as a transition diagram, it's better to convert the transition diagram into transition table. Okay, at the equivalence class 0, I'm just going to separate the non-final states and the final states. So which are all the non-final states? A, B, D, E, F, G, H. All these are non-final states and the final state is C. Right. Now from the equivalence class 0, we are going to identify equivalence class 1. What is the meaning of this equivalence class 1? From the given state, let it be A, B, C, D, anything it can be, we are going to allow the machine to read the string of length 1. So at the equivalence class 1, length of the string is going to be 1. Okay, so how do we build the equivalence class 1 from the previous step? Now I'm going to consider the states A and B. I'm going to check my transition table. From the state A and from the state B, on reading A, just to find out where it goes. From A on reading A, it goes to B. From B on reading A, it goes to G. So B and G belongs to the same set. At equivalence class 0, we have two sets in fact. One is non-final set, another one is the final state set. Isn't it? So from A and B on reading A, it goes to the states B and G, where B and G belongs to this set. Okay, fine. Now from A and B on reading the input symbol B, check where it goes. From A on reading B, it goes to F. From B on reading B, it goes to C. So F is in the set and C is in another set. So I can say that A and B are distinguishable because on reading a symbol of length 1, on reading a string of length 1, the resulting states do not belong to the same set. That is the reason. So I'm separating A here. Let me separate B here. And this set C you cannot further divide into, or you cannot find a further distinguishable states here. So just retain this step as it is. Okay, now A and B are distinguishable. Now what we have to do, check A and D in the same manner. Okay, so consider the states A and D. A and D on reading A, it goes to B and C. B and C are two different sets. So obviously D does not go with A. I mean to say A and D are different. A and D are distinguishable. So what can we do? Now just I will check whether the D can be merged with the set B. So I'm going to compare B and D now, right? I'm just going to check that whether D can be written along with this B. So B and D on reading A, it goes to G and C. Since G and C are also in different set of sets, so D does not go with B. So let me write D separately here. Okay. Now let me consider E. Right. So first let me compare A and E, whether both are distinguishable or indistinguishable. So A and E on reading A, it goes to B and H. Since B and H belong to the same set, fine. Now we have to check whether A and E on reading B, it goes to where F. Both the states A and E on reading B, it goes to F. So it belongs to the same set. Whether F is in this set or in this set, that doesn't matter. Whether the resulting states after reading the particular string, it ends up in the same set. That is what we have to check. So you can write E here. So at this step, A and E are indistinguishable. Okay, now let us move on to the next state, which is F. Now check whether A and F are distinguishable or indistinguishable. A and F on reading A, it goes to B and C. So B is in one set, C is in another set. Obviously we cannot write F along with A. Now let us check whether F can be merged with B. Right, so check. B and F you consider. On reading A, just check what are the resulting states. One is G, another one is C. So you cannot write obviously F along with B also. So skip this. Now you check whether F can be written along with D. Right? So you check D and F on reading A, it goes to C. So no problem. As of now, after reading A, we have identified this D and F are indistinguishable. What about on reading B? After reading B, it goes to the state G. So G is in this set. So obviously D and F are indistinguishable. Let me write F here. Now go to the next state, G. Start comparing A and G now. A and G, on reading A, it goes to B and G. We know that B and G belong to the same set. Now A and G, on reading B, it goes to F and E. Of course, F and E also belongs to the same set. So A and G are indistinguishable. So let me write G here. Okay, I hope the set closes by this. Okay, now let us consider the last step, the H. A and H we take. A and H, on reading A, it goes to B and G. Both belong to the same set. A and H, on reading B, it goes to F and C, but different sets. So A and H are in fact distinguishable. Now check whether this H can be written along with B. So consider B and H, on reading A, it goes to G. No problem. So B and H, on reading B, it goes to C, which belongs to the same set. So as of now, we have identified B and H are indistinguishable. So at this step, we identified 4 subsets. See, this is containing only single state. Further, you cannot do anything with this. Okay, you keep on disintegrating only this set. From there, we identified 3 subsets. Now, we are going to build equivalence class 2. Okay, when we try to build equivalence class 2, again the C, further you cannot disintegrate it, so you write as it is. But these sets, you have to look into it. When you are building the equivalence class 2, you have to build from the equivalence class 1. So how do I do that? Again, I have to repeat the same step. Consider these states A and E. Let me use a different pen so that it will give you more clarity. So now let us consider the states A and E. Go to the transition table. A and E, on reading A, it goes to B and H. Yes, B and H are present in the same set. So on reading A, it enters into the same set. Okay. Now A and E, consider A and E. On reading B, what happens? It goes to F. Of course, F belongs to another set. Anyhow, after reading B, both the states end up in the same state. So A and E are identified as indistinguishable even at this step. Now go for G. Okay, now once again check whether A and G are indistinguishable here. Consider A and G. On reading A, it goes to B and G, where B is in this set and G is in this set. So now the thing is, you cannot write this G along with this set. So write this G separately. Okay. Now you move on to this set, B and H. Okay, now let us consider the set B and H now. Okay, check whether B and H are equivalent even at this level. So go to the transition table. B and H, on reading A, it goes to G. Same state, so you don't need to check the set here, what it belongs to. B and H, on reading B, it goes to C. Yeah, even at this step also, B and H are indistinguishable. Now move on to D and F. Okay. So D and F, on reading A, it goes to C. Okay. D and F, on reading B, it goes to G. So D and F is still indistinguishable at this step. Yeah, we built the equivalence class 2. Now we have to build equivalence class 3. Now you may be having a doubt how long I need to build this equivalence classes. At one point, none of the states might be further distinguishable. You will be getting the same set of states. That is the point where you have to stop doing your problem. Okay, now we have these many sets: AE, G, BH, DF and C. Okay, G cannot be further disintegrated. Okay, now you have to take care of AE, BH and DF, and you have to check whether further it can be disintegrated or divided into subsets. Go to AE. A and E goes to B and H. Okay, same set, because B and H are in the same set. Okay, where A and E on reading B, it goes to F. A and E on reading B, it goes to F. So no issues. A and E are still in the same set. Okay, further it is not distinguishable. Sorry. Now G you have to retain as it is. Now consider the states B and H. B and H on reading A, it goes to G. Okay, then B and H on reading B, it goes to C. Again in this step also B and H are not distinguishable. Then go to the set D and F. D and F on reading A, it goes to C. On reading B, it goes to G. Okay, D and F are also not distinguishable further. And of course C also you have to retain as it is. Now check these two steps, you are getting the same set of states. This is where you have to stop, right? If you try even to find equivalence class 4, equivalence class 5 and so on, you will be getting the same set of states. Okay, now we try to construct the deterministic finite state machine here. I just draw here. AE is one state, G is another state, BH is one state, DF is one state, and C is another state. Okay, so just I'll draw the states. Since A is the final state, start state, this must be the start state. C is the final state, so this must be the final state. I'll circle 2 times here. So from A and E, on A, it goes to B and H. So this is the state. A and E, on reading B, it goes to F. So, yes. Now we move on to the state G. From G on reading A, it's a self loop. As per this transition table, I have drawn a self loop here. From G on reading B, it goes to E. E means wherever E is present, there you have to connect. Now let us come to the state BH. See, I'll tell you, give the proof now that B and H are indistinguishable. You see here from B and H on reading A, it goes to the same state G. B and H on reading A, it goes to the same state G. Same B and H on reading B, it goes to the state C. Yes, we are done with this. Now come to the state DF. D and F on reading A, it goes to the state C. That is what the transition table says. And D and F on reading B, it goes to the state G. From C on reading A, it goes to the state A. From C on reading B, it goes to C itself. That's all. Totally we have 8 states here. Now it is being minimized to 5 states. So this is the final obtained minimized DFSM. Please practice this problem. I'll meet you in another video with a similar kind of problem which is given in another question paper. Thank you.